Hello everyone, welcome back to LeetCode Daily Live, where I do the daily question raw and cuts. So we have a medium today called count complete. Let's see what the question wants. So you're given an array nums consisting of positive integers, and the bound is actually quite small this time, so it's only up to 1,000, and each number is only up to 2,000. So we call an array of we call it subarray complete if the following condition is satisfied. So let's see what it wants. So the number of distinct elements in the subarray is equal to the number of distinct elements in the whole array. Okay, I see. So return the number of complete subarrays. And also subarray has to be contiguous. So yeah, I think this question is not too bad. So what we have to do is we have to So we first have to count how many how many distinct elements are in the whole array, and then again we can use like the left and right pointer technique, right? So like if we start like with nothing, and then like our right pointer we want to go until we want to go until we have like 3 distinct elements. So how can we do that? Well, we can just use a map, and then we can store the frequency after, and we can just like use the length method to quickly get the distinct elements, right? And then let's say like, well, obviously my highlighted subarray here works. So if this works, we can add any we can add any of the like numbers afterwards to extend it, and it will still work, right? So that means like we have we have to find, well, the number of elements from the last element all the way to the from the last element of our subarray all the way to the end. So that's going to tell us how many subarrays we have if we start if we have our left pointer here, and then we want to shift the left pointer down, and it still works, right? So again, we have another 2 choices. But then when we shift here, well, we no longer have 3 distinct elements. So we just go to like shift up, and then, well, no, we don't get any more. So yeah, so we can just use this kind of algorithm, and it should work. What about this case? So if we start with 5, well, we have 4 elements, and then we want to move our left pointer up. So we'll move to like here, and then we'll move our right pointer. So it'll be like 4, 3, 2, 1, which gives 10. Yeah, so I'm not sure why this medium. Well, because like obviously you can do this in ON, so I'm not sure why it is 1,000 here. But well, let's just get coding. So we want to find number of distinct first. So a nice way of doing it is just turning it into a set, and then getting the length of that to get the number of distinct elements. And then we have left and right. Again, our right bound, we can make this exclusive. So that means like here we'll have no elements, and then when this gets to 1, we'll have like the 0th element. So while r is less than the length of the length of nums, so we can. So wait, what do we actually want to do? I think we want to move r. So our left bound is like at the very beginning, right? So we want to move r until our map has 3 distinct elements, like for example there. So we actually also need a map, so we'll call it like frequency. We can use default date to make things a bit nicer. So from collections, import default date. So what does that directly you do something like frequent x plus equals 1, because like when I do this, it automatically like set like it can initialize a new key as 0 from this int function. So I can just directly add 1 there without any fuss. So that's really good. So what we want to do here, we can just do if length of frequency is less than the number of distinct elements. Well, we want to increment our right bound and also add whatever is in nums r into our frequency thing. So we'll do that. So we'll add one there. And another case, so the other case is num distinct works, right? So what we want to do here is we should also have a count here. We can call it like, is it complete? Yeah, complete subarrays. So we can do like 0 here. So once we reach this point, we have our right bound at the place where left and right contains a subarray that is complete, right? So that means we can add, well, how many subarrays can we form? Well, it would be the length of nums minus r plus 1. Well, the plus 1 is because when r is here, yeah, so when r is here, I think r will be like equal to 4 here, right? So if we don't do a plus 1, it would just count all the elements after like r, but we actually want like not choosing any elements like after r could still form a good subarray, right? So that's where the plus 1 is from. And then we want to increment L, and also we want to decrement frequency. Well, we want to decrement like nums L because we are removing it from our subarray. And also so if frequency of nums L is 0 now, well, that means we don't have that element anymore, right? We should remove it so we don't actually count it here. So we can just do something like delete frequency nums L, and then we can increment it afterwards. So I think by doing this, oh wait, the only worry I have is here. So when we get to the end, so when r is, I think we should look at this case. So when r is 4, I think L will be 3 here. So it's going to add the element in. Yeah, I think like if we execute it right now, it's going to be missing like the last thing here, I think. Yeah, it's missing because like when we get here, we haven't really checked whether our subarray contains everything. So yeah, one easy way out is just complete subarrays. We just want to add one if our final length of frequency. Well, if you think about it, like if r wait, actually no, we should code it up here. So yeah, so actually we should do something like this. And yeah, so like our right bound can go all the way up to the end. But then when we get here, if r is equal to length nums already, well, we don't want to access the out of bound thing here, right? So we just break out of our loop. But like basically that means that if our r is at the end, well, because it is exclusive, we can still move our left bound up to like gradually count how many subarrays here, right? Like if it works. So that's why we should do this instead, and it should work. I think, unless I'm wrong. Okay, there we go. And yeah, thank you for watching, and I'll see you tomorrow. Bye.